Hello, I'm Jason Olsen from Baker Hughes Digital Technology Team. I, with my peers, are responsible for managing engineering and other technical software, annual software renewals, licenses, licensed services, and servers. I'd like to take you through our journey as we expand our license pools and infrastructure across Baker Hughes. We will cover several aspects of our journey. Perhaps some will be similar to what you have experienced or will experience. Topics cover are an overview of Baker Hughes, engineering software deployment, engineering software monitoring, monitoring tool selection, deployment strategy, current landscape, an ANSYS use case where we demonstrate value, our next steps, followed by questions and answers. Baker Hughes is a large organization in the energy sector with over 80,000 employees and contractors. Formerly, we were Baker Hughes International Inc., BHI, and General Electric Oil and Gas, GEOG, which merged into Baker Hughes, a GE company, or BHGE, in July 2017. Baker Hughes, a GE company, was independent from General Electric, even trading on its own stock symbol, BHGE. With GE as a majority shareholder at 5/8 of all stock, we enjoy some special benefits that are not available should ownership drop below 50%. Our relationship gave us access to GE's impressive buying power, IT infrastructure, new technologies, business processes, and overall global strength. The two legacy businesses began to integrate into one business, including HR and IT platforms. This was a significant shift as very little between the two organizations were done in the same way. Either way is fine, but together there is conflict and things quickly became very difficult. The GE underlying infrastructure was going to become the standard for BHGE. This includes PCs, servers, networks, identity management, and HR systems. The challenges we were facing were significant. Almost every time there are two typical options to solve an answer or a business need, legacy BHI had deployed a different strategy than GE's. It's similar to right-hand drive cars versus left-hand drive cars. They both work just fine, but driving right-handed cars on the right-hand side of the road is less natural than on the left. Some of the key aspects that the two legacy organizations differed include general control of how users access and engage digital systems. Legacy Baker Hughes limited what an individual can do, opting for requests and permissions to have something done to the infrastructure or systems. This includes extensive use of help desk tickets to get things done. Who and how different users and hardware access networks from very limited to and managed to more of a high level access request granted and reliance on individual software pools to limit use. Users of physical data centers versus aggressive approach to use cloud-based infrastructure. Cost capturing and budgeting is another area of great difference. This remains a challenge as slowly budgets from various organizations are harmonized to be aligned to one way of capturing the needs. GE always intended to reduce its ownership of BHGE from its 62.5% to something less. However, what wasn't clear was the timing of the divestiture and pace of sell down. In late 2018, GE was experiencing some financial and cash flow pressure. This may have accelerated GE's timetable for divesting in BHGE. Late in 2019, GE's ownership dropped to less than 50%, sparking off BHGE's separation from GE, including several mandatory actions such as separation of HR and financial systems. Baker Hughes, a GE company, became Baker Hughes. We entered separation from GE. This is a massive undertaking and will take several years. Different timetables exist depending on services, applications, or agreement. Each has its own parameters and contractual impacts. Having only recently gone through the exercise of integrating Baker Hughes International with GE Oil and Gas in the previous year and a half, we had a decent understanding of what it will take to separate from GE. Some strategies, such as harmonizing on GE's standards, were reevaluated and many times pivoted to a new strategy. More often than not, the old strategy of aligning with GE's approach was abandoned, and what legacy BHI had done would be adopted as a new way of doing things. The work ahead of us is significant, yet exciting to define how we want our company to look like and how we will do it. The two legacy organizations had different approaches to how software is provisioned and deployed to the user's PC. Legacy BHI required permissions to secure software, and the software typically was pushed onto a PC using SCCM software packages. Legacy GE Oil and Gas enabled users to self-install software. This includes shareware tools, applications purchased under local POs, as well as through workflows like the MyTech portal. Capturing costs, applying an asset back to a sub-business was common practice for GE Oil and Gas, but not for legacy Baker Hughes International. What processes a user follows is dependent upon the computer hardware, the base image of the PC, either legacy Baker Hughes International, non-admin rights, or legacy GE with admin rights. This is confusing for those who have more than one PC and need to follow both business processes if they have a PC from each legacy organization. We seek to quantify demand for software tools. This includes understanding who is using the tools, where they're located, when they access the tools, and for how long. Having two legacy systems continues to add complexity, as there are two Active Directories and not all user IDs or Windows login IDs are captured in both tools. This impacts enriching usage data, including adding in geographic and business parameters. Usage data aggregation across all networks and systems can be difficult when tools are used or key software pools do not have data captured. Through aggregation of data, we seek to reduce administrative costs by optimizing pool size as well as a number of pools offered. This includes site, region versus global licensing pools. With geographic and business data tagging, renewals and cost sharing can be applied. Divestitures and acquisitions are common for our organization. Understanding the impact to existing pools and capacity should assets be released with a divested business or need to absorb new demand from an acquisition. Actively managing software is something that has been somewhat inconsistently deployed across the two legacy businesses. Access control often is left to how software is installed and configured, so more of a passive strategy as opposed to blocking unauthorized users or checking for non-compliant use. Releasing hung sessions as well as identifying what sessions or users are idle typically was done manually, if at all. Very little is done proactively encourage use of preferred tools and discourage non-preferred tools. We have a lot of engineering and technical software packages, many individual pools from legacy businesses as well as pools that were managed and administered by other GE businesses. The legacy Baker Hughes International organization used Altera's Software Asset Optimization, SAO, to help understand who was using what assets, for how long, etc. There were well over 6,000 users covered by the SAO tool. Prior to SAO, legacy Baker Hughes International used Flexera's FlexNet Manager for engineering applications. The legacy oil and gas business had a 500 user count deployment of OpenLM. This for managing SOLIDWORKS users within a large business group to enable cost sharing or bill back across the various sub-businesses. The business was able to reduce SOLIDWORKS renewal costs by $120,000 through combining and reducing the total number of assets managed into 3 large pools as opposed to many smaller pools. Most of GE Oil and Gas did not have formal tools to help manage assets or usage. It was more of a local IT team's knowledge as they managed the software license pools. Through separation from GE, a team was assembled to address the software provisioning, access, compliance, and monitoring. The software governance team performed their analysis of potential solutions and integrations to existing tools such as configuration management database systems, and Flexera was a platform of choice with FlexNet Manager Suite or FNMS. However, not automatically included by Flexera was the FlexNet Manager for engineering applications. The team was down the path of securing Flexera's engineering module. However, based upon legacy Baker Hughes International's experience with Flexera's engineering module and legacy GE Oil and Gas experience with OpenLM, the topic was reopened for evaluation. Ultimately, OpenLM proved out to be the better choice based on features, price, and history of customer support. We opted for the following from OpenLM: License Allocation Manager, Vendor Daemons. Initially, 80 of those were purchased, but recently expanded to 260. 15,000 users and 15,000 active agents. Reporting Hub, roles and permissions, directory synchronization, group usage, project usage, and alerts. Our plan, still in execution, is to have all licensed services monitored with OpenLM and as many as we can be hosted in our licensed server farm. The server farm consists of 45 identically designed and configured virtual machines in North America, Europe, and Asia. We are looking to capture usage per user and associate it with the user's business unit and location to enable cost sharing or bill back or similar financial cost assessments to cover the costs of software renewal and expansions. Drive compliance through understanding who is using what and when and where. Capture software usage associated with specific projects, customer orders, or similar where projects are quoted as a cost plus. Automate licensed service restarts and automate notification of services going down. Have a dedicated 24/7 support team to ensure licensed services remain operational and available to the user community. Dedicated team to update license files, ensure server OS is up to date, and complete most internal administrative tasks. Historically, this was done by each license pool owner, and there were many owners. Automate the release of idle software sessions. Perform an analytics to determine pool right size using OpenLM native reports, as well as enhance analytics through Power BI desktop or other data analytic tools, and address denials of service. Currently, we have consumed 66 vendor daemons and average 8,800 unique users per month and are monitoring over 100 licensed services. Users continue to be added to our monitoring as license pools from GE are moved to Baker Hughes' landscape, and existing Baker Hughes pools are brought under monitoring. We have significant pools for Altair, ANSYS, AspenTech, Autodesk, SolidWorks, MathWorks, National Instruments, PTC, Siemens, and many other smaller packages. We anticipate having well over 200 licensed services to monitor, several triads deployed, a broad range of licensing technologies, FlexLM, HAS, RMS, and licensing pool strategies, concurrence, token, named user, site, and regional global license pools, and so on. ANSYS software licensing is very complex, as there are over 200 products with more than 300 different features. Just like a Swiss Army knife, some products have many tools, or features in the case for ANSYS. However, only one tool or feature can be used from the product bundle at any time. The product bundles vary greatly in price. Some may have many tools, This gives great versatility, but at a higher cost of ownership. This frequently is beneficial for smaller organizations that need variety of more so than overall capacity. As you can see from the graphics, some of these knives shown have common features, while others have new features not available in the other product or previous knife. Just like holding a knife, you can only operate one tool at a time and only one person can hold the knife. If a saw blade is needed, there are only two knives available. One is a more expensive version with many other tools. Should a tool only be available in the full featured knife be required, say the can opener, you will have to wait for the full featured knife or product to become available. This is an example of how our complexity of the ANSYS landscape, trying to use this with the Swiss Army knife visual. On the GE's ANSYS pool, there was seemingly limitless capacity based upon specific GE ANSYS agreement and deployment model. Users enjoyed having what they wanted when they wanted it. GE had a very long relationship with ANSYS, even co-developing and improving many of the ANSYS products. Some packages in the GE portfolio have been grandfathered in to their offering and not available for new purchases. This made mapping GE's usage data to our needs very difficult. GE had a special relationship for surge in demand capacities, and this also was not available to Baker Hughes under our new Baker Hughes ANSYS agreement. Determining the right size of the pool can be significantly impacted based upon the different kinds of demands that we see throughout the year. GE oil and gas business had developed many designs and analysis automations that call up ANSYS routines. This can cause sharp peaks in demand due to the rapid series of calculations getting initiated. Use of Cray and other high-performance computing resources enables a lot of work to be processed rapidly, as well as quickly consuming licenses, again, causing us spikes in demand. Early in the separation process, Baker Hughes stood up its own ANSYS pool. This deployment would prove to be one of our most challenging pools deployed. Fortunately, we had recently deployed OpenLM and were monitoring ANSYS pool. Very early on, we experienced significant denials of service. This would break the many automations and routines called up features and packages. We also had situations where these automations were referring to old ANSYS packages and package names that were not available. This again breaking our automations. The ANSYS user community was very anxious and people began to hoard licenses, not releasing them back to the pool at the end of the day. This further stressed an already fragile ecosystem. We needed to identify where to focus our attention, and using OpenLM was crucial in this activity. Focused, followed by monitoring, then implementing controls and behavior modification helped to quantify the problem. We then could purchase the gap between the current capacity and our reasonable likely capacity required. To gain focus, we used OpenLM's native reports, first being the feature usage summary. This provided a means of quantifying what features were in use at the moment and helped to guide us as to what else should be evaluated. The evaluation included contacting users to understand if they could use other features that were not in such high demand, or see if they could schedule jobs to another off-peak period. The Quality of Service report offers a clean and simple means of understanding how many seats we are using to ensure a specific level of availability. What is less obvious is how different quality of service levels actually feel, or how broad of an impact it has on the user base. Other than the obvious 100% or 99+% quality of service is good, from the user's point of view, it is less clear what the business impact would be at a lower quality of service level, such as 95%, 90%, or perhaps even lower. shortcoming of the quality of service became evident as there was no insights when demand exceeded capacity. Also, it treats all hours and days of the week equally. Having significant operations in Europe and North America, there are definite higher demand times of the day as those two time zones overlap. However, simply excluding the demand of regions outside of Europe and North America might lead to overlooking other key usage patterns. The denials of service provided to be another difficult report to fully understand, as it appeared to overstate the rate of denials. As can be seen by the chart, one user shows a huge number of denials. This might be more of a means of identifying potential squeaky wheels, those who will likely complain about a denial as they keep seeking a seat even when recently having been denied. These are great reasons why having active agents deployed can offer a better user experience and productivity. Being put on a waiting list enables a user to work on other tasks without having to repeatedly check for availability of a denied license. Using Power BI Desktop with a Reporting Hub SQL database, we could better visualize the problem by looking at unique user IDs for denials. The orange bars show how many denials of the feature happened. The number of adjacent lines indicates duration of denials and when they occurred, each line width being 1 hour of a day. The black line is what we have for overall feature capacity. However, this is misleading as a feature can be in many different packages, and as soon as a package is serving another feature, the resulting capacity is reduced. This is represented by the orange lines that fall below the horizontal black line. We could visualize and look to be the typical number of denials and give consideration to length of denial. We can approximate what additional capacity is needed to satisfy the typical demand. OpenLM has a native heat map view. This provides a quick means of visually capturing peak usage periods. However, there are downsides as a heat map is relative to the pool entitlement size. For our scenario, we had a temporary limitless pool to determine our ceiling, but everything looks green during that period. Initially, you see in red where we have denials, then in the dark green where we had a rapidly expanding pool capacity, and then we throttled back the pool size, as you can see in the yellows and the orange sections. Using Power BI, a similar but different heat map view is generated. Here, the heat map covers are relative to usage, not capacity. This analysis was conducted across a few specific high-demand features, but to simplify the discussion, I'll focus on the product ANSYS Mechanical that has the feature ANSYS. This is an expensive package and we own 79 seats. The data shown is from Power BI, but a similar view is available natively through OpenLM's web interface reports. We see the busiest times are from 8 a.m. to 6 p.m. GMT. The busiest days are midweek. And going through some of our key events through our process, as you can see, starting at the bottom, on May 6th, we show only Baker Hughes assets, and they're all utilized, 79 used. On May 7th, ANSYS provided an additional 25 seats, so we could find capacity. And as you can see here, that too rapidly increased to be fully consumed to 104 features, or our total population. On May 12th, we had to add an additional 475 seats to give us almost a limitless ceiling in order to understand where our maximum capacity is. And here on May 20th, we see a peak of 155 seats used at one period, perhaps averaging of above the 130 or so, which would be a gap around 50. To close that gap between what we own of 79 to 130 would be about a $2.7 million investment. On May 22nd, we communicated to our users about changes in some preferences. Here again is where what legacy GE had as far as the order of preferences and what we had in our actual pool were different and caused some conflicts where users would access the more expensive preferences first and not get to the lower cost preferences second. And these lower cost preferences sometimes had reduced capacity or capabilities. We see that after the communication, our peak usage is down to 140. And then on June 6th, we communicated with the users asking them to release idle sessions. And here the usage now is down into the 90 to perhaps 100 range. So we'll call that a gap of around 17, roughly $1 million or 1.7 million less than what we would have had if we were looking at just our peak demand. So I know it's a lot of information to process. Hopefully you can follow through the slide and understand that we do have some great value by understanding our peak demand as well as average demand and how the gap, close the gap between what we currently have and what our average demand typically is. Looking to the future, our next steps, we plan to categorize our different applications to different tiers, with the top tier are being our enterprise contracts, those that are really expensive, thousands of users, multiple sub-businesses involved. Often we'll have multi-year contracts on those. Mid-tier, which has a combination of cost, user base, and number of businesses similar to the top tier, but perhaps one of the threshold category is below the top tier classification. And then we have the bottom tier, which is the balance of our applications and the majority of what we own. We seek to build a rhythm around understanding usage, with the top tiers getting most frequent reviews and very deep analytics at the time of contract renewal. Reducing frequency and depth of analytics for mid, and then bottom tier is perhaps just an annual review. We seek to deploy our active agents across the enterprise to help us release those idle sessions, as well as monitor other tools. We seek to monitor the standalone and even non-licensed pool applications. And then we also look to capture project costs, so we can bid some projects as a cost plus strategy. So I'm looking forward to receiving some questions, and we'll go through our questions and answers now. Thank you.